Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another Godot tutorial for our mobile RPG, the turn-based series that I'm doing. If you've enjoyed this series so far, please consider supporting my Kickstarter. There will be a link in the description and a card. Let's get started. In this video, part 3, we're going to be adding some more logic to our enemy, because currently when you run the game, you can hit the enemy, but it just kind of takes down on the health and not really a lot happens there. Let's hide our preview there, so we've just got this, the mock-up. And it's just not a lot happens. So let's fix that. So first, we're going to want to take this enemy and make it its own scene. Scenes in Godot are a little bit tricky to grasp at first, but they're extremely powerful. So you can see we have this scene set up called Battle Scene, and we're using it kind of similar to a room like you would in GameMaker, or it's just an area that the game happens in. However, there's another thing you can use scenes for, and that is something more similar to like an object in GameMaker, or something that is in the area that the game happens in. And one of the cool things about this is that each scene can be instanced or put into other scenes, and so you can chain them. So maybe you have a scene for a house, you could have a scene for a chair, you could have a scene for a city, and you put the house inside of the city and the chair inside of the house. And so that kind of logic suits games pretty well. In order to make our enemy its own scene, we're going to right click on this right here, this node, and come to save branch as scene. It'll bring up a save menu, and we can just save as enemy like that. And now you can see the enemy is still inside of our battle scene, but it's got this little scene icon next to it. And you can also see that we can no longer see the children nodes of this enemy. We just see the enemy now. If we right click on it, we can do Editable Children, which would then show us the children and allow us to change them. But we don't need to do that. Yes, we want to disable Editable Children. We don't need to do that because if we click on the little scene icon here, it opens up our enemy inside of its own scene, like this. And you can see that it's positioned in the same position that it was over here. And generally, you don't want that to be the case. You want its position to be 0, 0, like this. And we'll just save that. And then if you come into battle, you can see our enemy is now positioned at 0, 0. Which we don't want that. Inside of here, we want it positioned down here. But inside of its own scene, we want it on the origin like this. So we'll leave it on origin in its own scene, but now inside of battle, we'll move it down. And let's turn on our mock-up again so we can get it about where we want it. Oopsies. Let's lock the mock-up so we can't see it, or we can't select it. And then we'll drag our enemy down just, wait, I keep grabbing UI. Let's lock it. There we go. Now we should be able to move enemy just down a tad more. Do Control S to save. Hide the mock-up again. And let's make sure that that worked. Yep, it did. So the enemy is now positioned properly there. But if we click on our scene icon here, it's at position 0, 0 in its own scene. Now we can work on this enemy because it's going to be a slightly complicated scene, more complicated than the other elements of our game. So that's why we're making it its own scene, is so that we can kind of work on it individually. And this helps you separate your logic. So we've got all of the logic for our enemy in here, and you can actually run the enemy if you click this button up here. This will run this scene instead of running the game. And So you can separate out your logic that way. So every single scene should be able to run on its own. And you can see our enemy does. It can run on its own. It can run without giving us any errors like this. And that helps you to decouple your code so that each individual thing is its own element, and all of the code inside of it can be run on its own. And then you use all of those elements to build a game and put it all together. And as your game gets bigger and bigger, then those individual elements, you don't have to worry about how they affect everything else. You only have to worry about the logic inside of them. And it just makes your code more manageable as your game scales. Okay, so let's start actually doing some stuff with our enemy scene here. So the first thing we're going to want to do is add an animation player node. So look up animation player. And this node is a very powerful node that we can use to create our own animations. And we're going to want to do that. So let's create an animation here. If you click on the node, it should open up an animation tab down here. And if you click the animation button, we can create a new animation. And we're going to call this one Shake. And this will be an animation that plays when the enemy gets hit. And now we've got a little timeline down here. And we can scrub through this timeline. And we've got the length of the timeline. So we've got it at 1 second. You can see we can come to 1 second. And then we've got the intervals as here. We've got 0.1, 0.2, 0.3, right? And down here you can see the snap is set to 0.1 intervals. Okay. Now we're going to animate our enemy, and up here at the top, when you've got an animation node selected, there are some different, I guess you would say, properties that you can animate. So we've got location, rotation, and scale. And for our purposes, we're only going to need to use location, so we can uncheck rotation. And we're going to be animating the enemy sprite. We don't want to animate the actual enemy position, because if we were to animate that, then that would affect the position here in our room. So we just want to animate the position of the sprite relative to our enemy's actual position. And so let's come back into our animation player, and we've got our shake animation. So we can, we're probably not going to want it to run for this long. We're going to want to do a much shorter amount of time that it runs for. 1 second is too long that it'll be shaking. So let's do 0.2. And we'll want to zoom in a bit so that we can see better. I don't know that we can zoom in more, maybe. Oh yeah, we can. There we go. Drag it this way. And we'll want our increments to be on 0, 5. And so now we should have a little too zoomed in, maybe. There we go. So that gives us a total animation time of 0.2 and increments of 0.5. So we've got 1, 2, 3, 4, 5 frames, except this frame and this frame are similar. Basically 5 frames that we can work with. So on our first frame, we're going to key the sprite's position. You can just press this little key button up here, and it will ask if we want to create a new track. We say create, and down here we can see sprite and position. So we keyed the sprite's position. Then we can come to another location. We can move the sprite, say here for example, and we can key the sprite here. So we'll key it here. And it shouldn't create a new track. We want to make sure that we're keying the sprite position. Then we'll key up here. Key. Whoops. Well, it doesn't matter, but we need to move our track over and then key up here. And then we'll move over again and key maybe right here. And then we'll move to the end and key down here. Now you can see our characters jumping around. If we play this animation, it kind of shakes around. You can click this to loop the animation. You can see how it looks when it's looping. It's pretty fast. Okay. Now you can see that Godot interpolates between the frames. So when we come from this frame to this frame, when it's playing, it actually does it. It actually moves smoothly between this position and this position. So automatically interpolates between those frames. And I'm gonna move this up just a bit. Seems a little too exaggerated. There. And there. So actually we want it to end on center, but that's okay. And you can see we've got a shake animation. So we can use this whenever the enemy gets hit. Maybe you don't want it to interpolate smoothly between frames though. If you don't, you can come over here and you can see we've got some options here, a little drop down menu. We've got continuous, that will interpolate smoothly, and discrete, that will just jump between the positions instantly. And you can see the difference there, how much jumpier this one is. I think I'm going to leave it to be continuous, so it will be smooth. I think that'll look fine. We'll see. And once we've got that, I'm actually going to, we can manipulate these points if we want to a little bit. So this one, for example, I could drag clear over here, the very first one, and I'm going to do that. This one I could drag to the start, move this one, move this one, move this one, and then drag this, our starting one, to the end. That way our starting position is actually down here now, and then our ending position is actually centered. And I'm going to save that. I'll just do Control S to save. And I'm going to create a new animation. Well, that should be fine. We just want our animation to end with our rat centered again. And this should work just fine to get us what we want. Now, we need to have access to our animation player. So click on the enemy script up here. We'll do on ready var animation player equals animation player, like that. And so that should get us access to the animation player. And whenever we get hit or we lose HP, we'll want to play our animation, the one that we set up. So inside of here we can say animation player dot play, and then in here we can get some animations. And let's get rid of this here. And it's a string value of the animation that you set up. So ours will be shake, like that. We can save and run the game. And now when the enemy gets hit, it should shake a little bit. And it shakes the same way every time, but you could set it up to where it didn't shake the same way every time, or have multiple animations where it picked between a few different ones. That would be another way to make it not shake the same way every time. But I think I'm just going to leave it this way so it shakes the same way each time we hit it. And this gives us a lot more feedback when the enemy is hit. We can still go into the negatives though, so let's fix that. So let's create a new animation. Well, no, not animation. Let's just handle that inside of here. Instead of set HP, our setter function, we'll say if HP is less than or equal to 0, Q free, else play the shake. We don't want to try and play the shake animation if it's just going to be destroyed anyways. So the queueFree function destroys the node that we're currently on. We'll destroy it. And it doesn't destroy it right away. It waits till a more convenient time for processing to destroy it. And the benefit of that is sometimes your node is in the middle of doing something. And if you just call, there's another function you can use, it's just called free. If you just call free, it might interrupt that process. And so queueFree says basically at the end of this frame, get rid of this node. And this is generally the one you want to use. So it queues the node for being destroyed, basically. And if we run, now we can see it destroys it. However, if we click on sort again, oh, we're going to get an error message because it says, what is enemy HP? I don't know what that is, right? And this is inside of our battle script. So let's come back into battle. And inside of here, the problem is that we're getting access to the enemy when this, at the very start of the game. But then if the enemy is destroyed, then it's trying to access it again, but it's no longer, this reference no longer is correct. And so what you can do here is you can say, instead of getting enemy up here like this, you can say var enemy equals enemy, just like we had before. And then you can say if enemy does not equal null, enemy.hp minus equals 4. And so this will get this. There are two ways you can do this. One way is to actually have the enemy set the battle variable to null or some other thing when it gets destroyed. And the other one is just to try to get the enemy every time you use the sword. And I'm just going to go for this system because it's easier. And the code is more contained inside of this single script. I don't know that it's necessarily better, but we're still getting an error message now. So it says not found enemy, and it's trying to get the enemy like this. So what this system right here won't work for this because it's trying to find enemy and gives us an error. However, there's another function we can use called find node. And you can just pass in a string value for the name. And find node will not error if it can't find it. So now we're no longer getting an error message. But this all kind of defeats the purpose of this anyways, because once the enemy's there, maybe you don't want to, well, there's different ways you could do this, honestly. But the way that I've chosen to do this is to actually hide the buttons that are down here when the enemy is destroyed anyways. And so that's one thing you could do, is just hide those. And we could use a signal for this. So inside, you can create your own signals, because we've used signals before in the last video, but you can actually create your own signals inside of a node. So if we come into our enemy scene, click on the script to make sure we're under the enemies script. We'll hide the animation player. Inside of here, up at the top, we can do signal. And we can call it on death. And that seems like a pretty good name, I guess. And then inside of here, when we destroy the enemy, when we call queueFree, like this, we can also send out a signal. And we'll call it, or we'll say emit signal on death. Or maybe died. Let's call it died. That seems like a better name. Okay. So we can emit this signal when the enemy has died, and then we can do something when that happens. So if we come back into battle, we can click on our enemy here and come over to node, and you can see now we have our own signal up here that we created. And we can double click on that and connect it to battle. Do connect. So this is on enemy died. See, I like that name. It would have been weird if it was on enemy on death or whatever. Inside of here, we could hide our UI. So we could hide all the UI. We can set our system back to what we had before, where we have enemy equals enemy, and then we still have our this would be an onReady var, and we still have our if enemy does not equal null here, but when the enemy dies we can set enemy equal to null and solve that problem. And then we could, we're solving the problem twice here, but we could then hide the sword button. So if we got access to it, onReady var sword button equals sword. Let's see. I'm not sure why my autocomplete it doesn't seem to be working right now. Not sure what the deal is there, but the path should be UI sword button, like that, I think. There we go. And then we could just hide it here. We could say sword button dot hide. And if we run the game, once the enemy is dead, it hides the sword button and we can no longer click it. It's still there, just hidden. And so that's pretty cool to have that set up. We're going to be setting up an attack for our enemy as well. So if we come into our enemy and then animation player, let's click on animation, do new. We'll call this one attack. And we'll set up a new animation for this. And our attack is going to be, 1 second seems good. We're going to have to zoom out just a bit here. And there we go, that's good. So let's create a starting position. We'll click on the sprite and key a starting position, do create. Make sure that it's actually at 0, 0 here when you key your position. Then we'll come down to 3 in, and this will be our wind up for the attack. So we'll actually come up just a bit here. It should be our sprite, so we'll key that position. And then we'll want to maybe come to 0.4 here, and we'll come down a bunch, like to here or so, and we'll key this position. And then all the way at the end, we'll be back at the starting position. So we'll come clear to the end here, move our sprite back up and key this position. You can see, seems like a pretty fast jump there, but when you play the animation, you can see it's a pretty good attack. Might be a bit too long. Let's set this to, no, not 0. Holy cow. 0.8. There we go. Let's try setting it to 0.8 and see how this looks. That's some of the feedback I got from people, is that it was a little too slow, and that looks better. And if you want, you can come over here to these options again and do cubic here, which smooths out the motion just a little bit. And that looks really good, I think, for an attack for the enemy. Perfect. So we've got our enemy attack set up. let's have for now, let's have the enemy attack every single time the player hits the enemy. Eventually we're going to make it so the player has action points and the enemy will only attack once the player is out of action points to use. But for now, we'll make the enemy attack every single time the player does. So how do we do that? Well, we've got our sword button pressed, so we know when we're attacking, right? And this triggers inside of our enemy, this triggers the shake animation right here. So you can actually, there's a way to wait until this animation is finished and then play another one right after. And we can do that using the yield function. So we can say yield animation player. So this tells it what we're going to, well, let's see if I can remember this right. Let's see if I can fix my autocorrect real quick, or my autocomplete, I should say. Project, quit to project list. Come inside of enemy, here we go. It doesn't seem to be working. I'm not sure what I did. But if we look at the documentation and look up yield, you can see that it takes an object and then a signal for that object. So it waits until whatever signal has been fired. And so we can say animation player is our object. And then the animation player, if you click on it and come up here, you can see it has an animation finished signal. And so we're going to use that. Animation finished. So this next line of code, line 20, won't be run until our animation player has signaled that its last animation has finished. And this is very powerful when you're making turn-based games, because this allows you to run an animation like we're doing right now and not do anything else until the animation is finished. And you have to do that quite often in turn-based games because something happens, then you play an animation and you want to not do anything else until the animation is finished. I mean, if you think about the Pokemon games when they first came out, the Pokemon would use an attack and it would show the animation, right? And then it would take down the damage afterwards on the enemy. And so that's what we're doing here. And then we can do animation player.play attack. And this structure is not really the best way to structure this inside of a setter like this. But we're just getting started. We'll be changing the structure as we get a little bit farther into the video. And you can see we hit the enemy and then it attacks us. Hit the enemy and then it attacks us. Now if you hit it with the sword button while it's still playing its attack, or while it's still hit, then it doesn't get a chance to actually use its attack. And if I show you in the example project that I set up, I actually, while the enemy's attacking, I actually hide all the buttons down here. And that's how I solve that problem. So they can't click on them because they're not there. So we could do that as well. We could have it hide all the buttons whenever we use our attack. And then after our attack is finished, then we could show those again. And that's probably what we'll end up doing. But for now, I think this is going to be all we're going to do today on this video. We've got a nice little animation for when we hit the enemy, and then an animation for the enemy attacking us back. And if you deal all the damage to the enemy, it will disappear and be dead. So thank you so much for watching this video. Part 3. I will be working on part 4 this week as well, trying to get that out here soon. So keep an eye out for that. Thank you all so much for the support, and I will talk to you all later.